Why is there something rather than nothing? The answer is there had to be. If you have nothing in quantum mechanics, you'll always get something. It's that simple. It doesn't convince any of those people, but it's true. Now, great, we know the universe is flat. But if you've been awake, you realize 10 minutes ago I proved the universe was open. There's only 30% of the stuff in the universe needed to make it flat. Where's that other 70%? Well, if you put energy in empty space, so empty space weighed something, you wouldn't see it. It's the empty space between the galaxies. You're far away from the galaxies, you wouldn't see it. But what would that empty space do if you put energy in it? Well, it produces a cosmological constant. That would cause the expansion of the universe not to slow down over time, as any sensible universe should do, but to speed up over time. In 1998, people measuring these supernovae at large distances to measure the Hubble diagram tried to see what was happening at large distances to see if the universe was slowing. Well, they all knew the universe was slowing down. They wanted to measure how much. This doesn't look like much, but it was a revolution in cosmology. I can draw a straight line through that data set there and bring the whole thing down and make it horizontal. And if the universe was slowing down, these distant supernovae should have followed this curve. Much to the surprise of the observers, the supernovae lay above the straight line. And the only way to explain this, well, there's two ways. Either the data is wrong, which it usually is, or the universe is accelerating, speeding up. And if just for fun one believed it was speeding up and asked how much energy would you have to put in empty space to make it speed up by the amount we measure it, it's exactly the amount we are missing. Everything holds together. Our new picture of cosmology is that we live in a universe dominated by nothing. The largest energy in the universe, 70% of the energy in the universe, resides in empty space. And we don't have the slightest idea why it's there. Now, that's what I just said. Let me also put an aside before I get on to the rest in the last 5 minutes of the talk. This completes, in some sense, the ultimate Copernican principle. Copernicus told us we didn't live in any place special. We now know two things. Well, one thing. I'll tell you the second one in a second. This tells us that we are more insignificant than we ever imagined. If you take the universe, everything we see, stars and galaxies and clusters, everything we see, if you get rid of it, the universe is essentially the same. We constitute a 1% bit of pollution in a universe that's 30% dark matter and 70% dark energy. We are completely irrelevant. Why such a universe in which we're so irrelevant would be made for us is beyond me.